You are quite familiar with vertical columns. They have been around for centuries and are still used today. But as humans, we always evolve and always try to develop creative ideas. The revolutionary idea is that columns don't necessarily need to be vertical all the time. Columns cannot be designed to be inclined. Nowadays, homeowners usually care about the aesthetic view of their homes. So, because of these aesthetically pleasing needs and also some other structural benefits, structural engineers tend to design an inclined column. This inclined column is not found often in structures, but due to client demand for a good aesthetic view of their homes, the inclined column is designed. The degree of inclination of this column will usually depend on the designer intention. But the design and construction of an inclined column are not as easy as a vertical column. It can really be a challenging and difficult task to construct on site. Inclined columns can be designed and constructed with various materials such as concrete, steel, and timbers, or they can even be precast. Let's try to understand the design mechanism of an inclined column. Let's see how they actually work from a design standpoint. When a column is inclined, there will be an axial force acting on the column and also a horizontal force perpendicular to the cross section of the column. This type of column is designed as normal vertical columns, but there will be additional bending moments. Due to the eccentricity, this additional bending moment usually occurs. Because these columns are inclined, the eccentricity moves away from the midpoint. As the inclination of the column increases, the eccentricity also increases, resulting in a higher moment on the column. A higher moment in the column will mean a larger area of steel will be needed in order to cater for this moment. So, special attention need to be paid to the changes in stresses due to the eccentricity of the axial load on the column. Inclined columns are more susceptible to second-order effects than vertical columns because of their inclination. When this column is inclined at an angle to the beam or slab supporting the column, there will be a significant change in the bending moment due to the eccentricity of the axial load acting on the column with respect to the longitudinal axis column. When you are analyzing this inclined column in software like ETAB or StatPro, the software will automatically determine the additional moment developed due to the eccentricity. It is essential that the contractor be 100% precise when it comes to the reinforcement, the fixing of the formwork, the pouring of the concrete, and also the settling of the column. Because of the additional reinforcement of this inclined column, which will make the column congested, the contractor, when pouring the concrete, should use a concrete vibrator that will allow the concrete to properly flow and cover any gaps. If this is not done properly, it can cause honeycombs on the inclined columns, and we don't want such thing to happen. This is pretty bad because it can lead to the failure of the inclined columns.